This week in Math 70, we're looking at systems of equations. So a system of linear equations in particular is a pair of equations. We have two variables, x and y, and two equations. So if there are two variables and you have two equations, there's a good chance there's a solution, and a solution is a point. So one equation can be viewed as a line, and the other equation can be viewed as a line, and often those lines will intersect. So here the question is, given this linear system, does the point 5, 2 make a solution for the system? So that means 5, 2 has to be a solution for the first equation and the second. And we can just plug it in and see. So here I would have 5 times 5 for the first equation, plus 2 times 2. And I'm wondering, does that equal 29? So we just do the arithmetic. So I get 25 and 4, and that does equal 29. So it's definitely a solution for the first one, so I'm on the right track. Then I try the second one. So 8 times 5 minus 1 times 2, and we're hoping that equals 38. And so we do our arithmetic, so we'll get 40 here, and then we'll get minus 2, and 40 minus 2 is 38. So it turns out the point 5, 2 is a solution to both equations. So that means it's a solution to the system. The first equation right here is this red line. The second equation here is this blue line. And you can see that my computer graphing system here marked this point, which appears to be x equals 5 and y equals 2 there. So I can confirm graphically that that's the solution. So finding a solution, there's a few different ways we can do that. Sometimes we can graph and find the solution. Other times we'll have to do some algebra to solve the solution. So let's try another one. So here I have the system in my open math to solve it, and I'm asked to graph the first line, graph the second line, and place a dot indicating where they meet. So here I can graph pretty easily by using the idea of the y-intercept and the slope. So for the first one, I would use the line tool here to mark -4 as a point. And then the slope says to go down 2 and over 1, which I can't do here. So I'm going to reverse that, go up 2 and left 1. So there should be another point right there. And the line tool on my open math will take me right through that. So I'm going to use the line tool here, maybe. So this line does something like that. Okay, so there's my first line. We'll leave it blue. The other one has a y-intercept of 0, -3. So let's switch to blue points for that one. So 0, -3 is going to be about here, and its slope is -1. So that means I could go down 1, right 1. There's a point. I could reverse that and go up 1, left 1, 8. And I think I found where they met. I'm going to graph that, change the color. So that graph looks something like this. Got it right? And so I can visually on the graph then switch to the point tool and say they meet right here. And then I've solved the problem. So I'm just going to write down that solution and check it aside from the graph. So I think, according to this picture, that the point -1, -2 is the solution. So that means if I plug in each of these x and y values into each equation, it should make them both true. So let's try the first one. The y is -2, and that's supposed to equal -2 times x, which is, I believe, -1 minus 4. And so cleaning that up, oops, I have an extra parentheses. -2 times -1 is 2. 2 minus 4 is -2, and that's nice because that matches what I thought should be on the other side. So check, this is a solution to the first one. Try the next one. y equals negative x minus 3. So we believe y is negative 2. And then we want the opposite of whatever x is, which we believe is negative 1, and then minus 3. So all we're doing is plugging in this x and that y into the equation. Then, we're hoping that's true, so we have to do the arithmetic. The opposite of negative 1 is 1. 1 minus 3 is negative 2, so I get negative 2 equals negative 2, which is a true statement. So I just confirmed by plugging in that this point that the graph showed me is definitely a solution to both equations. All right, let's try another problem. So here I'm asked to graph the system on my own instead of using the graphing tool in my open math and identify the solution. So I have to figure out how to graph y equals y minus 6x equals 23 and y plus 3x equals negative 4. So let's let the first one be red. I'm going to rewrite that by adding 6x to the other side. So I'm going to say that's y equals 6x plus 23. So that tells me I have a y-intercept of 23 and my slope is 6. So I'll attempt to graph that in a minute. The other one, we'll do that in blue. Y equals, I'll have to subtract 3x to the other side, so I'll get negative 3x minus 4. So as far as y-intercepts, I need to scale my grid here so that I can get up to 23 and down to negative 4. This one has a positive slope, that one has a negative slope. So this red one's going to go uphill, blue one's going to head downhill, and they should meet somewhere. All right, so let's see. We'll put the y-axis, just throw it here for the heck of it. And the x-axis, I have to get to 23. So now I have to look at my paper and figure out how that's going to happen. So how many marks do I have? Start here. 1, 2, 3, 4, 5. Is that right? 1, 2, 3. Oh, I did 4. Oops. There's 5. 1, 2, 3, 4, 5. So graphing is an art, right? You got to get the right part of the grid. I'm sure I can talk and count here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5's at the very bottom. All right, so 5, 10, 15, 20, 25. All right, this will work out good. So I'm going to make this right here 25. And so this would be 20 on the y-axis. And this line here is what, 15 and 10 and 5 and 0 is here. So I'll just draw that as an axis. So here's the x-axis. You don't have to scale x and y the same, but you can. I think it'll work out here if we scale by 1 again. So 1, 2, 3, 4, that would be negative 5. 1, 2, 3, 4, that would be positive 5. And down here is negative 5, right at the bottom. All right, red graph says to start at the point 0, 23. That would be right there. And the slope 6 over 1 you could view as up 6, right 1, which is off my screen. So I'm going to reverse that. I'm going to go down 6. So 1, 2, 3, 4, 5, 6, and left 1. And then down another 6. And then, oops, I don't have the point there. Left 1. And down another 6. And left 1. And let's keep going a little more. Down another 6. Left 1. Did I do that right? So I have 1, 2, 3, 4 points, and I went over negative 1, negative 2, negative 3, negative 4. Okay, so I got that line. Let's draw it in. From here up through there, something like that. Okay, other one, switch to blue. That one says to start at the point 0, negative 4, which is right here. And that says to drop 3, go right 1. So that's off my screen, so I'll reverse that. So instead, I'm going to go up. 1, 2, 3, left 1. Up. 1, 2, 3, left 1. Ooh, look at this. This is nice. Up. 1, 2, 3, left 1. And I think I found my point of intersection. Up. 1, 2, 3, left 1. And we'll draw that line. Looks something like that. To the best of my ability. A tiny bit off, but close enough. All right, so it looks like we have a point of intersection. The point of intersection appears to be right here, and that would be, let's write that in black, -3, 5. So we could have messed up our graph, so we got to double check. So before I write it in my answer spot here, I'm going to plug the x and the y in here and see what happens. So into the red one, if I plug in a -3, let's go down here, I'll get 5 equals, hopefully, 6 times -3 plus 23. 6 times -3, that would be -18 plus 23 is 23 minus 18, or 5, which matches the other side. Check. For the other one, let's plug it in the blue one. Y is 5, we believe. -3 times x is -3 minus 4. Hopefully, negative times a negative is a positive. 9 minus 4 is definitely 5, and check. It checks out in both of them. So I did find the solution. It is -3, 5. Cool. All right, let's see. Do I have any more listed here? No. So let's look at some other ways of solving these. And I'm going to start with, might as well use this one here. On a new screen. So another method for solving besides graphing, so I'm going to get rid of graphing. I'm going to use a method called substitution. The way substitution works is you solve for one variable, so for example, in the first equation, I can easily solve for y by adding the 6x to the other side. So I'm going to get y equals 6x plus 23. And then what you do is you use that to plug in or substitute into the other equation. I'm giving you a crash course in this whole chapter. So what does that mean? Well, my equation here claims that y is the same thing, equals 6x plus 23. So anywhere else I see a y, I should be able to replace it with 6x plus 23 because they are equal. So I'm going to replace this into the other y over there. So the other equation had a y, but instead I believe y is equal to that. So instead of writing y plus 3x equals -4, the equation above says I can replace this y with a 6x plus 23. And whenever we do a substitution, we should put in parentheses to be safe. And I copy down the rest of this. Plus 3x minus 4. We've seen equations like this a lot throughout the terms, and all I have to do is solve this. Order of operations, I should do inside the parentheses, but there's nothing to do because 6x is not like 23. But so I could remove the parentheses and take 6x and add it to 3x because they're on the same side. So this is the same as 6x plus 3x plus 23 equals -4, and 6x plus 3x is 9x. So we've collected like terms. Now it's time to move things around. So this 23 can move over to the other side. And let's get a new page. Let's see, -23 combined with -4 is going to give us a -27. So I now have, oops, wrong way. 9x equals negative 27. To break that multiplication right there, I divide by 9. And that gives me x on the left side. And on the other side, 9 goes into 27 3 times. Negative over a positive is a negative. So this tells me that x should be negative 3. To find y, I just go back to one of my original equations, like y minus 6x equals 23. Plug in this x value and see what happens to find y. So this is my, let's see, we did our substitution. So I guess step 3 here would be then to solve for the leftover variable. Step 4, plug your number into one of the original equations. So we're going to get y minus 6 times negative 3 equals 23. Negative times a positive, that's going to give me y plus 18 equals 23. In this case, we'll subtract the 18 over to the other side. These guys cancel. Let's come over here. So then y is whatever 23 minus 18 is. On a good day, that's 5. So I think I have a solution now. Negative 3, 5. The last step would be to then plug both numbers into the other equation to see if we really got it. So my other equation was, let's go back and look, y plus 3x equals negative 4. And we're going to plug in to test this out. Negative 3 for x, 5 for y. Excuse me. So that gives me y is 5. Make sure you get them in the right spot. 3 times negative 3. And this is supposed to equal question mark negative 4. So let me just do arithmetic. Positive times a negative is a negative. So that gives me 5 plus negative 9, which is just like 5 minus 9, which happens to be negative 4. On the other side, we have also a matching negative 4. So check. We do have the solution. So that is solving by substitution. And I'll come back in another video, and there's a bunch more on the website about solving with elimination. We could also graph those like we did before, so you can use a combination of techniques. If you want a good graphing utility, Desmos is a nice app you can use on your computer or the calculator. So I'll just give that a try here. Close that and start over. So if you just search, by the way, we'll start over completely. Leave, search for Desmos on your computer or your tablet or your smartphone. You can go graph, and the one we just did was y minus 6x equals 23. And the other one was y plus 3x equals negative 4. And here we got lucky that the intersection is on the screen. Sometimes it's not on the screen, so you might have to move the screen around. You can just click and drag to do that. Alternatively, you can zoom in and you can zoom out and move it around again. And here, if I click on one of the equations, it'll tell me important points. Important points here would be, for example, the x-intercept, the y-intercept, and where it meets other things on the screen, like the point negative 3, 5. So it's not sufficient to just use Desmos to solve problems. Sometimes it's going to give you decimal answers and you're going to need exact ones. So here, for example, if I was looking for the x-intercept, negative 3.8333 is an approximation. It's not the exact value, so I'd have to do a little algebra to figure that out exactly. But at least I know what the approximate answer is. And sometimes these points of intersections will be fractional or decimal, not whole numbers. It all depends. So have fun, do good math. I'll see you soon.